Okay, for homework 329, I'm going to have you check your work against mine and then write down the 5 words to show me that you listen. All right, so for this one, I move this around, but then I want you to see, even though it's moved, I still have parts of it that are exactly the same. Just because it's moved around doesn't mean the sides are any different. So if I'm comparing the original EF to the new E prime F prime, yes, that will be the same. That will be true. That is true. EF, this distance right here, is the same as this distance right here, even though it's been moved. Angle F is the same as angle F prime. And yes, that is true. Even though I'm moving it around, those angles don't change. That is true. And then the last one, angle D is a bigger angle than D prime, and that would be false because D and D prime are equal. So if you're saying one is bigger than the other, that is a false statement. First word is surf. Surf. All right, second problem. We want you to see if you do a reflection, parts of the triangle or any shape are equal. Parts that are equal distance over the line you're reflecting over, the x-axis, these are equal. All the parts that are equal distance, those are equal. So again, those are the parts you're looking for, the choice that has the correct pair. It says H and B, and I can see those not across from each other. F and C. Let's look at that. Ooh, F up here, C down here. Yep, I'm thinking that one's good. A and G. Nope. D and F. Nope. So the only one that works is F and C, right smack across from each other. Those are the equal ones. All right, next. For this one, we want you to describe this in words. I could see that this is a translating left, don't say slide, and then a flip or a reflection over this x-axis. So that's what I'm going to write in math words. You could say figure 1 is translated to the left. So from 1, I'm moving to 2, translating to the left. Then reflected. Let's write that word better. Then reflected over the x-axis. So you have to make sure you say all that. Translated and which direction. Reflection and which line it's reflecting over. Don't want to say slide, don't want to say flip. Translated to the left, then reflected over the x-axis. Second word is snow. Snow. All right, for this one, they want you to focus on H, knowing that it is a clockwise to the right. It's going to move over here to the right. I know it's hard to see that that's to the right, but that is to the right. If I look at the H point in the pre-image, remember this beginning one is called the pre-image. That is the point 1, 2, 3, 4, 5, 6, -2. If I do a quarter turn to the right, the new H prime is going to have those points flip, and then that right one, after I flipped it, becomes the opposite of what it once was. So that becomes -2, -6. I would plot the new G, left 2, 1, 2, 3, 4, 5, 6. This is where the new H will go when it does a quarter turn to the right. If I was doing a quarter turn to the left, which you need to know, that would be a 90-degree counterclockwise turn. I would do that same trick of flipping the points around, but since I'm turning it to the left after I flip it, it's that left one that becomes opposite. So that becomes the new point 2, 6, if I could erase that right there. So that would be a quarter turn to the left, 2, 1, 2, 3, 4, 2, 6. And then for those of you who are starting to see this, you could look at it in terms of like squares rotating. Look at that square right there, rotating to this square right here, or rectangle. You can see that corner is moving down to this corner right here. This square is moving up. Sorry, this rectangle is moving up to there for a quarter turn left. I'm not sure if that helps out any. All right, next problem. Number 5, we want you to describe this transformation. It is growing, so it's a dilation. They give you a sentence starter. So I would use that exactly. Triangle A prime B prime C prime is a, and then make sure you write this. This is a dilation because it's getting bigger. It's not flipping, it's not spinning, it's growing. A dilation of triangle ABC by a factor of, and it's whatever number I'm timesing by. And if I look at this point right here, B, which is 1, 1, the new B is 2, 2. Looks like I'm timesing by 2. This is multiplied by a factor of 2. Every single coordinate is being times by 2. That original C, which is 4, 1 for the original C, if I times that by 2, gives me the new C prime, which is 8, 2. You can see that is right. That is 8, 2 right there. So again, when I do a dilation, every number in each coordinate is times by that same number. Every coordinate number times by 2 to make it grow. So that would be triangle ABC is a dilation of triangle, I'm sorry, A prime, B prime, C prime, dilation of triangle ABC by a factor of 2. All right. Third word is sand. All right, this one we want you to do a 180 rotation, knowing that it will end up always, you guys, upside down. For it to get that upside down look, you just take the coordinates and you just opposite them. If I look at this G point right here, that's the point -2, up 3. That is the point for G. If I opposite that, that will become +2 and -3. Opposite those, that's the new G prime. Notice I didn't flip nothing. That's only quarter turns. Opposite is when you do 180. Leave the points alone, but just opposite them. So -2, 3 becomes 2, -3. That's the new G prime. If I look at F up here, F is -1, 2, 3, 4, -4, up 1, 2, 3, 4, 5, 6. If I do the opposite of that F point, that will become 4, -6. So here it is, over 4, 1, 2, 3, 4, down 6, 1, 2, 3, 4, 5, 6. That is F prime. And if I do the other ones there, I will see that the new D, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 will be right here. Again, upside down. The new E will be right here. Upside down. When you do a half turn, they end up across from each other upside down. Only quarter turns get this sideways looking look to it. Otherwise, it's upside down. All right, next problem. This one, I want you to see that they're definitely not congruent. They're not equal, but they are similar for sure. They're similar. And then, of course, if they're similar, then you don't want to pick this one, neither similar nor congruent, because you said they're similar. On these, I'm telling you, if you reflect it, a lot of these reflections with rotations are not going to work. So some kind of little hint to you, if there's any problem talking about a rotation in here, you don't want to pick it. The only one that's going to work for the second one is this last one here. Let me show you why. If I take A and I first reflect it across this x-axis right here, it will end up upside down underneath that line. Then if I reflect it across the y-axis, it will be equal distance right here across the y-axis line. And then you can see it grew. To get from there to B, it grew. And if you really want to see, it is growing by a factor of 2. That point right here, that used to be the original point when I did the first reflection, is 1 for x, negative 2 for y. This new point right here for the growing part, you could see that point right here is the point 2 for x, negative 4 for y. It took that original one up here in blue and doubled it to get that bigger point. Every point has been doubled. This point right here, doubled. It used to be 1, 2, 3, 4, negative 2. Now it's 8, negative 4. It doubles. So again, that's the only one that works. Reflect it across the x-axis, across the y, dilate by a factor of 2, and the fact that they are similar. Fourth word is mountain. Mountain. All right, for this one, I want you to see that is a reflection over this y-axis first. That's what I would do if I was you. Reflect it over the y-axis first. And then 1, 2, 3, 4, 5, 6. Count how many boxes I'm translating down. So I could see if I reflect across the y-axis, then all I got to do is count down 1, 2, 3, 4, 5. So that one, I'm going to use their sentence starter. Triangle, look at that capital letter. Triangle ABC has been reflected across the reflected across the y-axis. Sorry if I spelled across wrong. And translated down 5 to form triangle A prime, B prime, C prime. That's what I would write on that one right there. All right, almost done. Number 9. For this one, again, we want you to see all the angles and what they mean. If I look at angles A and B, those are right next to each other. Those plus to be 180. That is a good answer. Yes, those do add up to be 180. F and C, these with my eyeball I could see are the same size, or on either side of that line through the middle, that transversal line, angles on either side always equal. But if I look at F and C in terms of 180, that's not going to be good, because two angles that are equal don't add up to 180. If I wanted an angle in there to add to F or C to get that 180, I would have to look at maybe like angle F and then add that to angle G to get 180, or maybe angle F and E to get 180, but definitely not F and C. All right, next one has me compare A and C. Where is that? So I got A right here, C right here. Definitely congruent. Yep, those are what we call corresponding angles. Corresponding. All right, vertical angles. I got C and H. And yes, those are right smack across from each other. Vertical. Yes, vertical angles are equal, congruent. Last one, F and G are congruent. And you can see that is a no. Those add up to 180. They're supplementary, but they're not congruent equal. And again, hopefully you could see just with your eyeball all the angles that have the same opening. And then hopefully you could see with your eyeball the angle sets that when you plus them together give you that 180-degree angle, that straight angle. I want you to be able to see that. All right, keep going. Number 10, piece of cake. Number 10, find this angle first right here by knowing that this 98 plus this unknown angle equal 180. So what you do to find that missing angle, since that 98 and that missing angle equal 180, you take 180 and subtract 98 from it, and it will get you what that angle has to be. What's left to get it to be 180? So 180 minus 98 gives me 82. That angle is 82. Don't put that as the answer though. And now to solve for that X angle on the outside, I add these two up. X is equal to the two inside angles. That exterior angle is equal to those two inside angles added up. So 82 plus 34 is going to give me 116. That's where I put that right here. Angle X is 116 degrees. All right, number 11. This one, they want you to see that if this is 65, these are corresponding. Those are equal. So if that's 65, then this angle is 65. Angle B is 65. Don't put 65 in angle A. Don't put it there. Angle B is 65. Make sure you read. But to find angle A, I gotta again go back and know that these two add up to be 180. And if I give you a part of it, you could do the math to subtract to find that missing piece. 180 minus gives me 115 degrees. That's what angle A would have to be. So when I add up 65 and 115, I get 180. That has to be 115. All right, problem 12. All right, here we go. Back to this one. If you have different number of x's like this one, it has 3x on one side, 0x on the other, that is an instant one solution. If you have the same number of x's though, but a different number right here, that is the always the no solution look. And then the rest. Sometimes you got to distribute. Like this one, I have to distribute first to see what I get. But then when I do distribute, I see same x's but different numbers. That is a no solution. If I look down here at number 4, different number of x's, that is a one solution. And if I look at this last one here, if I combine these like terms before I could look, that gives me 2x plus 4 and another 2x plus 4. That is the same in every way, not just the same x numbers, but the same numbers as well. That is your many solution look right there. All right, almost done. For this one, I want you to try to explain in words why there's no solution. Maybe type what you get after you distribute. So maybe in that box you could type 5x, show me after you distribute, plus 10 equal 5x plus 20. And then maybe you could write the linear equation has no solution. Look at that sentence starter. The linear equation, use those sentence starters, has no solution because any number I plug in will never give me a true true statement, I should say. And what that means is when you have 5x plus 10, no matter what number I keep plugging in for my answer, it will never give me a balanced equation, because one side I'm timesing 5 by 2, the other side I'm timesing that exact same 5 and 2, but one side I'm adding 10, the other side I'm adding 20. That will never give you a true solution answer, because one side I'm always adding a different number than the other. So maybe you could write that in your math explanation. You know, plugging in like a number 2 will not work, because on one side I'm adding 10 after I'm timesing 2, and the other side I'm adding 20, maybe something like that. All right, last problem and last word. This one, we want you to solve it and then know in a sentence explaining why it's correct. So if I distribute this, that gives me 4x minus 16 plus 2x equals 8. I'm going to combine my like terms right here to get 6x minus 16 equals 8. Now that I've distributed, up here this is distributing, and I combine like terms, this is combining like terms. Now I could start my inverse operations. Add 16 to both sides. Bring that 6x down. This gives me 24. Divide both sides by 6. And for this answer, I get x equals 4. For your sentence, you could say the correct value for x is 4. I know this is correct because if I plug in 4 to x, I will get a true statement. And maybe, I don't know if you want to try to type that in words. What that means is if I take that equation and I replace that x number with the 4 that I know it is, it should give me a true statement. It should make that equation work. Let me try to show you. Of course, that new solution, that no solution one, you'll never get one that works. So that gives me 0 right there. Remember, anything times 0 is 0 and goes away. So this becomes just plain old 8 equals 8, which is a true statement. That is true. Last word is wave. Wave. So show me, turn in all this work and the words. Be ready to show me that tomorrow. Good luck.